Welcome to our first webinar on cylindrical roller bearings. In this session, we'll take a look at how these specialized rolling bearings are designed, how they work, and what different designs are available. Let's start with a brief introduction. First, we'll explain what a cylindrical roller bearing is and how it differs from other bearing types. Then we'll break down its design and key components. After that, we'll look at the difference between point contact and line contact, and what that means for load capacity and speed. Next, we'll walk through the different designs and their functions. Finally, we'll wrap up with a quick preview of what's coming in the next webinar. Let's get started. Cylindrical roller bearings are part of the radial roller bearing family. What sets them apart is their cylindrical rolling elements, which run between the inner and outer ring. Compared to ball bearings, these rollers provide a larger contact area perpendicular to the roller axis. As a result, cylindrical roller bearings can carry significantly higher radial loads, they are stiffer, and they can achieve the same load capacity with smaller rolling element diameters. That's why they are commonly used in applications where high forces have to be transmitted, such as machine tools, gearboxes, or conveyor systems. The design of a cylindrical roller bearing is straightforward but engineered with high precision. It consists of an inner ring, an outer ring, and the cylindrical rollers in between. Depending on the design, the inner and outer ring may include flanges. These flanges guide the rollers along the raceways and determine whether and in which direction the bearing can take axial loads. In bearings with a cage, the flanges also help keep the rollers separated so they don't touch each other. This reduces friction and heat generation, which allows higher operating speeds. Cages are typically made from polyamide, brass, or sheet steel. Many parts of a cylindrical roller bearing are deliberately contoured, including the roller end faces, the flanges, and the raceways. These geometries support an even distribution of lubricant inside the bearing. Reliable lubrication is especially important because cylindrical roller bearings generally have a higher proportion of friction than ball bearings. One of the key differences between ball bearings and roller bearings is how the rolling elements touch the raceway. Balls create a point contact, while rollers create a line contact. Point contact supports higher speeds, but it comes with lower load capacity. Line contact spreads the forces over a much larger area, which is why cylindrical roller bearings can carry significantly higher loads. In practice, that usually means they run at lower speeds, but in return, they are extremely robust and durable. This principle is exactly why cylindrical roller bearings are mainly used in applications with high radial loads. Cylindrical roller bearings come in a range of designs. The main differences are the flange arrangement, the number of rows, and the type of cage. Among the most common single-row radial cylindrical roller bearings are the designs N, NU, NJ, NUP, NF, NH, NUB, and NJP. N-design bearings have two fixed flanges on the inner ring, while the outer ring has no flanges. This allows the shaft to shift axially relative to the housing in both directions, which helps compensate for thermal expansion and installation tolerances. New design bearings are the opposite. They have two fixed flanges on the outer ring, while the inner ring is flangeless. They also allow axial displacement in both directions. With the addition of an angle ring, the bearing can be axially guided and then provides not only radial support but also axial support. NJ design bearings have two fixed flanges on the outer ring and one flange on the inner ring. In addition to radial loads, they can carry axial load in one direction. With a suitable angle ring, The bearing can also be supported in the opposite axial direction. NUP design bearings feature an outer ring with 2 flanges and an inner ring with 1 fixed flange plus a loose flange ring. This design axially locates the shaft in the housing and can carry axial loads in both directions. NF design bearings have 1 flange on the outer ring and 2 flanges on the inner ring. They can take axial loads in one direction. NH design bearings are similar to the NJ type, but they include an additional angle ring, meaning a removable flange ring. NUB design bearings have 2 fixed flanges on the outer ring and none on the inner ring. The inner ring is made wider on both sides. This design also compensates axial displacement of the shaft relative to the housing in both directions. NJP design bearings have 2 fixed flanges on the outer ring and a loose flange on the inner ring. They are used to guide the shaft axially in one direction. These different designs make it possible to match a cylindrical roller bearing very precisely to the load case and the installation conditions in the machine. And that brings us to the end of our first webinar on cylindrical roller bearings. In the next session, we'll take a closer look at the different designs and variants, explain the benefits of multi-row cylindrical roller bearings, and introduce some special design options. We look forward to seeing you in our next video. Thank you for your attention.